Hi everybody, I'm Professor Rad, and today we're going to talk about a second type of measure of center called the median. So let's go ahead and take a look at what this looks like. So the median of a data set is the value that's in the middle after you've arranged the data in order from least to greatest, so from smallest number to biggest number. So two things you want to make special note of here, and then we'll do a couple examples. So first, you have to make sure your data are in order, otherwise it's not going to work. And secondly, if you have an odd number of numbers in your data set, there's going to be one number that's in the middle. But if you have an even number of numbers in your data set, you're going to have two numbers in the middle. So in that case, what you do is you basically find the mean of the middle two numbers. So you add the middle two numbers and then you divide them by 2. So we're going to do one example with an even number of numbers and an example with an odd number of numbers, so you can see what that looks like. So for these examples, we're using the same data sets that we used when we were looking for the mean. So just as a refresher here, so in this example, Chuck is looking at a simple random sample of 12 senators and a simple random sample of 15 members from the House of Representatives. So we're going to find the median of these two data sets. So if we have our data sets looking just like this is not set up well for us to use or to find the median because the numbers aren't in order. They're kind of just, in whatever order they were found in. So to help us out, what Chuck has done here is he has arranged the ages of the senators in order from least to greatest. So we can see that they're in order, so we don't have to worry about doing that. And then same thing with the House of Representatives. They're already listed in order for us. So almost, I just noticed the 63 is out of place here. Uh-oh. That's a terrible typo. So let's adjust that. There we go. All right, so let's go ahead and find the median. So I'm just going to double check. There should be 12 here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. All right, very good. So to find the median, we want to find the value that's in the middle. So I'm going to start crossing out from both sides. So I'm going to cover up the 76 and the 35. And then I cover up the next two and the next two and so on until I get to the middle. And now I see that there are two numbers that are in the middle. So to find the median, I'm going to add those two numbers together and then divide that answer by 2. So 68 plus 70 is going to be 138. And we'll divide that by 2. And that's going to give me 69 years old. What this means is that half of the senators in the sample are older than 69, and the other half are younger than 69. Let's now take a look at the House of Representatives data. So same game, we're going to start on either end, kind of matching them up, and keep going until we get to the value or values that are in the middle. Now this time, notice when I move over the last spot, that leaves us with just one number in the middle. So that's because we had an odd number of numbers. So when you have an odd number of numbers, just that number that's in the middle is going to be the median. So 58 years old. So based on this sample of data, the senators have a higher median than the members of the House of Representatives did. So you might say, on average, the members of the House of Representatives are younger than the senators. Now remember that word average could mean any type of average or measure of center that we're going to be discussing. So the word average doesn't necessarily mean add everything up and divide by however many there are. Okay, that's just one type, that's the mean. The median here is another type of average. Now we can also find the median for data that has been presented in a frequency distribution. So let's talk about how we could do that. So first, what you want to do is find the halfway point. So the formula I've got here is by adding 1 to the number of numbers. So in this case, n is if you add all the frequencies together. So n is your sample size or your population size. So you figure out how many people were surveyed, add 1 and divide by 2. Then what you're going to do is you're going to add those frequencies until you meet or pass that halfway point. And then your median is going to be in that category. So let's go ahead and actually, let's go back up here and see why that halfway point formula works. Because you might be wondering, like, okay, divide by 2 makes sense because we're cutting the data set in half, but why this plus 1? So let's look at the House of Representatives data. And I believe there were 15, but let's just double check. 1, 2, 3. Yep, 15. So in this case, n is 15. And if we look at the value that we wound up finding for our median, that would be 8. That's the 8th number. So let's try this n plus 1 divided by 2 formula to see if we end up with 8. That's what we're looking for, which number in the list. So if I do 15 plus 1 and then divide that by 2, 15 plus 1 is 16, and 16 divided by 2 is 8. So this is how I could find that this is going to be the 8th number in the list. Now, if I have an even number of numbers, let's see what would happen. So remember up here with the senators, the value for n was 12. So let's do 12 plus 1 and divide that by 2. So 12 plus 1 is 13. And half of 13 is 6.5. So if I count up these numbers here, 1, 2, 3, 4, 5, 6. Notice that that first number is the 6th number. And here we have 6.5. It means we have to go beyond 6. So when this formula gives you a decimal number, it means you want to take the number that's in the 6th spot and the next one, add them up and divide by 2. So if this little like location kind of formula gives you a decimal, that means you want to take that object and the next one, add them up and divide by 2. Whereas if this formula gives you just a single number, you're just going to take the value that's in that spot. So let's apply this now to a frequency distribution. So this frequency distribution shows, let's see, how much money a simple random sample of kids got from the Tooth Fairy. Okay, so that's what we're looking at. And we want to know what's the median amount of money that the Tooth Fairy was giving. So first, let's add up those frequencies to find our value for n. So 8 and 2 is 10, 15, 16. So n is 16. And if we do n plus 1, divide that by 2, 16 plus 1 is 17. And if we divide that by 2, we get 8.5. So we've got this decimal. So that means we're going to be looking for the 8th kid and the 9th kid. And we're going to add the amount of money that they got up and divide by 2. So if I just start counting here, these are the first 5 kids. So I haven't gotten to the 8th kid yet. If I add 8, I get 13. So that means these 8 kids are the 6th, 7th, 8th, 9th, and so on, up to the 13th kids. So these 8 kids are happening in that middle overlap spot. So each of those kids got $5. So that means the 8th kid got $5 and the 9th kid got $5. So if we add those up and divide by 2, we're going to get $5 for the median. Now, this is what mathematicians would call an elegant way of solving this problem. It's kind of shortcuts and a quick way of working through it. You're kind of using this table to, to your advantage. But I also know that this is not a straightforward approach. Elegant solutions are sometimes not very straightforward, and you kind of have to remember the process or truly understand what's going on here. So if you have trouble kind of thinking about this process and that halfway point, let's draw a picture or kind of list out the data actually to see what's going on and see why this works. So as I was looking through this, I said the first 5 kids each got $1. So I'm going to write out 5 ones. So 1, 2, 3, 4, 5. Then the next 8 kids each got $5. So I'm going to draw out 8 5s. 1, 2, 3, 4, 5, 6, 7, 8. The next 2 people each got $10. 1, 2. And then the last person got $20. So what I've done here is I have recreated our data set, kind of going backwards from what we did when we created frequency distributions. I've taken the frequency distribution and recreated the data set. And now I can use my technique that we used for the medians. Now, because I had so much data, I put it on 2 lines. So instead of using my fingers to kind of navigate here, I'm just going to cross them out in pairs. So the 20 and the 1 match up. The 10 and the 1 match up. This 10 and this 1. A 5 and a 1. A 5 and a 1. A 5 and a 5. A 5 and a 5, and that leaves these 2 5s in the middle. So for this, my median will be 5 plus 5, divide that by 2, and I'm going to get $5. So here's how this location comes into play. So the 8.5 means these 2 should be the 8th and 9th numbers. 1, 2, 3, 4, 5, 6, 7, 8, and 9. So that's what's going on. We found the 8th and 9th numbers, added them up, and got our median. Here's what that looks like in this process of when I was adding my frequencies. So I said, here's that 5. That's the first 5 people. So that's covering those first 5 people. Then we added this frequency of 8 and got to 13. So I know that that category is going to go up to the 13th person. So when I'm adding in that category, I notice I've passed those 2 numbers that were used for that median. So they have to be in that category. And so that's how I knew that they were both going to be 5s. So if you have a frequency distribution and you kind of forget the elegant way of doing it using this formula, then you can always go back and recreate the data. If instead you looked at this and you're like, I don't know why you're going on about this, Professor Rad. I thought that frequency distribution made sense. That's fantastic. Then feel free to use the shortcut. The only time I think that the shortcut is worth it is when instead of single digit numbers for these frequencies, what if we had 52 and 803 and 2061? You wouldn't want to have to write 2061 copies of 10, right? In that case, it would be a lot easier to use this technique. But if the n is small enough, in this case just 16, then you can go ahead and recreate that data set and get through and find your solution in pretty much the same amount of time. So that's one of the advantages of knowing multiple methods. You can work through the method that makes the most sense for you. So that's going to wrap it up for this video about the median. In the next video, we're going to look at a third type of measure of center called the mid-range. So looking forward to seeing you then. In the meantime, have a wonderful day.